Hi everyone, welcome back to Audio Develop. My name is Joel. I'll be your instructor for the day. Thank you for subscribing. Thank you for following the channel. If you're new to audio, C++ and audio DSP, this channel is all about teaching you from absolutely scratch. So that means I'm not assuming you know C++ and you know audio programming or digital signal processing. If you can read code and you're curious, you're actually in the right place. So in the last episode, we built our very first program. It was a very small program that actually took sound from the microphone and sent it straight to the speakers. So we can say this was just the hello world of audio programming. But right now, it's not something real software like will ever ship. It is using the default audio device. It only works with mono, and we can't even control the volume. So today we are going to fix all of that slowly and carefully. So by the end of this video, you'll see every audio device on your computer. You'll choose which ones to use. You'll convert mono sound into stereo because currently it is mono. And you'll control the loudness using gain. So this episode is still the foundation of all audio software. So don't worry, we are still in the foundations. Now, right now, my computer has multiple microphones connected, and it has multiple speakers connected, and it also has a USB audio interface. So our program will not magically know all this. So professional audio software always does the same thing. It normally asks the operating system what device exists, show them to the user, let the user choose. So that's what we'll build today. Now, we had two functions. We had the audio callback and we have the main function. Now let's go to the main function first. We want to first list all our devices. So it's important to know that audio devices are normally chosen before any real-time audio begins. And it is never inside the callback function. It's never inside here. So first we need to find a way to ask PortAudio how many devices exist. Now, right after this PA initialize, we want to get rid of this. Let's just get rid of this first. We said PA initialize is actually telling PortAudio to initialize. So right after the PA initialize, we want to call PortAudio. And we're going to say int num devices get device count. Yes. So what is this telling? What are we doing here? We are calling PortAudio, and it is asking us how many devices does the system have. Now, it's actually storing the number in num devices, okay, in form of an integer. So if this number is negative, something went wrong. So we're going to do a loop here. So we're going to say for, I'm going to say int inum. Let's just get rid of this first. So we are starting a loop here, and I is actually the device index. So we need to repeat this loop once per device. So That means everything that is inside this loop runs once per device. So we're going to do this. We are going to say a constant PA device info. We're going to say PA device info. It's supposed to be a pointer. Then we're going to say the info. Okay, info is equals to PA get device info. Now we are asking PortAudio for information about the device number, and then store it into info. Now we are storing the information into the info. So think of this as a label attached to a device. Now we can do something like can do a printout here, so that see out, and we can say I, and then what do we say? We can say, okay, yeah, it's actually giving us something here. Okay, and we can say info name, but we don't want to end the line. Here name. Okay, we can just do this. Can do this. Can also say I can say inputs. I think that will be the best. Okay, I can say inputs. Max input channels. Yeah, okay, so I think I'll just drop this down. You can just tap that, then you can drop this down. This is the input, so we're getting the inputs. Let's just do this. I think this will be best for us to keep it neat. So what's happening? We've said we are storing the information into info. Then what this is actually adding, it is actually printing how many input devices, input channels, how many input channels the device supports. So 1 actually means mono microphone, and 2 means stereo microphone. So I also have this. This is actually printing how many output channels I have, and how many output channels the device supports. And it ends the line and moves to the next device. Then of course we are closing the loop. So we're closing this loop. So we are actually at this point all the devices have been printed. Now we want to have a way of asking the user to choose. We want the user to choose. The user is able to see the list, but we want them to pick. So we're going to do an int. Then we say input device index, input device. Okay, so what's happening with my keyboard? Okay, input device index, and we're also going to say output device index. So what this does, it is actually creating 2 variables, one for the microphone selection and one for the speaker selection. So we're just going to print out we can do a printout, and we can say std cout, and we can say, what can we say? We can say select the input device. Simple. Yeah, select. You can, okay, let's remove this index. Select the input device. Okay, then we can also say, yeah, we need the C in, so okay, nice. Then we also need to select the output device. Then of course we need to C in. What's happening here? We are actually printing a message to the user, like, select the input device. Then here we are actually waiting the user to type a number. Then it is actually the same thing for the output device. Right now we are still having mono input and mono output. Now we want to tell PortAudio how we want our audio to flow. Before opening the stream, we need some kind of a structure that will describe our input device. So I think we're going to create something like a PS stream. Again, I am doing this live, so hopefully we're going to do a parameter there, PS stream parameters. Then we're going to say input params, param. Then what? Yeah, I think hopefully this is what will work. Yeah, so what is happening? I'm just creating a structure that describes our input device, and then we need to use the device the user selected. So it will be input device params. Okay, input device, input params. So then we're going to say the dot device, and we're going to say, yeah, this is actually correct. So meaning the user will be able to use the device he selected. Now, so we're going to say input params channel count 1. Yeah. So why are we using 1? We want mono input. That means we want one sample a moment in time. Then input params sample format. Yeah. Audio samples are normally 32-bit floating point numbers. This is actually a standard for DSP. So we're going to do something. Suggested latency is equals to PA get device info input param. Let me do this calling input param, input params dot suggested latency, of course, yes. So we need to tell PortAudio to get the device info. So get the device info. Then I'm going to say input params. It's supposed to be a device index. So it's going to be input device index, of course. Then it's supposed to point to default low latency inputs, default low input latency. So what am I doing here? I'm asking PortAudio for safe. Okay, let's put this first. So I'm asking PortAudio here for safe low latency settings. So we are not guessing, we are actually asking the device. Now we need to do the same for output parameters. We need to create some kind of a description. So okay, so this is creating. So we are creating the output description. Could be good to comment. Yeah. So we have to use the selected speakers. So we'll just say output params dot device, output device index, So we are using the selected speakers. Then we're going to say output params dot channel count. Now instead of 1, we'll say 2. 2 is actually stereo output, left and right speakers. Then you're going to say output param sample float. Same sample type as input. Then we're going to get the low latency playback. Default low output. Okay. Let's just do this output param. How did I write the params? Output params shall be the suggested latency, which will be PA. Of course, I'm just copying directly from the input. So PA underscore get device info. Then I can say output device index. And then we say the default low latency output. Low output latency. So now with that done, we need to modify this a bit also. So we're going to get rid of this now pointer. Then instead of these, we shall get rid of this. Then we shall have, we'll convert also this to input params. Instead of 1, we'll say input params. Then also this, we will change this to output params. We'll get rid of this because already we've said here this floating point. We have sample rate, and we have the frames per buffer. We need a flag. So we need to tell PortAudio we need a flag. So PA no flag. Then we have the audio callback. Then now with that done, we want to now implement the core DSP, which is the gain. So before audio starts, we need to define gain. So we'll just come just below here. We'll do something we call a constant expression. Again, XPR, and we shall say, because we said DSP is actually float, we shall say float gain 0.5. So this means every audio sample will be multiplied by 0.5. So this will make the sound quiet. No, now this is DSP. Now we have to go to our audio callback function. You remember we said this is where the DSP is actually happening in this for loop. So we need to do something, because remember this, where in was actually pointing the incoming samples, and out was where we write sound, and then we come to this loop where it is looping every over time. So one iteration is equals to 1 moment in time. So we need to change this. So currently it is input and output. So we have to multiply, because gain is actually multiplication with a constant, which is this 0.5. So what we are going to do, I'll just comment out this. I'll just remove this first. So this is what we are going to say. Float sample shall be equal to ni times gain. So what does this mean? This is actually now the real DSP. I can just say apply gain. This is real DSP. This is the first. This is our first DSP. Now we are reading samples, then we are multiplying it by gain, then we are storing the results. So we have to do something we call stereo interleaving, so that the left and the right can get the same sound. So as you can see, IntelliSense is actually giving us chord prediction, so that is actually right. Then we are going to do for the right channel. Perfect. So this means the stereo output is actually interleaved, so they will both get the right channel. So that's it. Imagine that is DSP, our first gain. We've done our first gain, so we need to close here. Oh yeah, it's closed. Before we run it, let me explain this. We said sound in a computer is numbers over time. So DSP, or digital signal processing, just means changing those numbers into math. So gain is normally output is equals to the input times gain. That is, so gain simply is output is equals to input times gain. So that is basic. That is what gain is: input times the constant, which is gain. So gain, which is constant, you can say which is constant. And now let's see what is, and yeah, which is constant 0.5 exactly. Now that's it. So we need to build this and check and test it out. So need to save it. So we are going to do cmake. Okay, so because I'm already in the build folder, cmake, I think I'll get an error. So we're going to make. So let's try making, and there we go. So we have an error in the PA open, and here we go. Okay, where is it? Where? Okay, so here we go. So what is happening in here? Why are we getting this error? So we have the PS stream. Yeah, now I know where the error is. So I told it to use open default stream instead of open stream. So that is why. Yeah. And that's it. So let's just try again, make. Perfect. So let's try it out. Okay. As you can see, it has actually listed the device currently connected. So I have the AAA, which is my monitor, my 4K monitor, my audio interface card, the Behringer 44. I have the Havit headphones, as you can see. I have an external headphone too. I have the Mac Mini, and we have the Microsoft Teams. So I will select so the input device. I'll select what do I use? Let me use the Havit to avoid locking out the audio interface card. Select the output device. I'll go with the Havit. So 3. All right. Okay, it's supposed to continue. It's just supposed to continue. So let's check from here. So okay, let's just remove this clean audio. I don't think I need these because I'm opening up a stream. Yeah, I'm opening up the stream. Then so let's just remove these. Then we are starting the stream. So let's change these. I think this will be very much important. So we are starting the stream. So we can do an std cout stream started. Yes. Then I think we can do something like, okay, can remove this. Then we can see, because we have streaming started, we can do an stdc in dot ignore, so that you can try and ignore. Yeah, so that we are actually waiting for user input to stop. Yeah, exactly. Then we shall get Yeah, so I see where, wait for you a second. Yeah. Then we'll just remove, do you need this? Okay, PS stream, we don't need this error. Don't need that. Even this we don't need. Is that string we don't need, so we'll change this. So we are stopping the stream, so we don't need this. Close stream, then terminate. Yeah. Okay, so let's try to make it again. And let's try to make, and let's run it. So the input device should be 2. Input device should be 3. Yeah. So it is not stopping. So we had to change this here. So it is currently waiting for user to press enter to stop. So, okay. Now, right now we have gain and we are able to select our audio devices. Right now we are using a constant gain. Now, we want to have a way, we want a way we can change gain from the console, and a way we can print the current volume level or the gain level without UI and not GUI, because currently we are still at the basics. So that means we'll have to add a global gain parameter. That means we'll have to store the gain in an atomic float. So when I say an atomic float, I mean the STD atomic float. So what does that mean? So that means we will store the gain, then the audio callback will read the gain, then the main thread updates the gain, then main thread will actually print the gain safely. So this is what we'll call real-time safe, beginner-friendly, and it will be very easy for you to understand this concept. Now let's modify this. So we have the input-output level. Let's add the atomic header file include. So atomic, because we'll have to. Why are we using the atomic? So audio thread and the main thread both should have access to gain. So normally the STD atomic normally guarantees a safe reading and writing, and it doesn't have locks or waiting. So we need to create a global gain parameter. So what is this global gain parameter? So we'll use something we call the STD atomic, and we are going to say float. Then what shall we call it? G gain, yeah, global gain. So because I had used, I will comment this out first. Then I will say, instead of gain, I will write 0.5. Okay, so this is actually a shared volume knob, and it starts at 50%. So starts at 50%. So it's starting at 50%. So the audio thread will actually read it, and the UI thread will actually change it. So we need to use it in the audio callback. So what is going to happen? Inside our callback loop, where we had set the input times gain, we are going to modify it. So we are going to modify it with, instead of gain, we are going to use the ggain.load. Now, let me explain this. This load is actually reading the current value safely. That means we will not have any locking, we will not have any blocking, and it will be real-time safe. So we need to print the current volume level. So we said we don't do any printing here in the audio callback. So where the audio, the main thread after starting stream is, that is down here below, we need to actually print out the current audio. So we shall do it. Audio stream started. Let's do it below there. So we can do the std cout. Then what do we call this? We shall say current gain level. Current gain level. Then ggain load std end line. So what we are doing here is running it outside the audio thread, because it will not affect any timing and it will be very safe for us. So right now, let's try to run it. Let's try running it. So I'll just make it again. Then let's run it. So input, we said, is number 2 on my side, output number 3. So you see we have the current gain level at 0.5. So we are going to stop that. Now we want to change the gain level while the audio is running. So we are going to use a simple loop. Now, where will we change this while it is running? So we'll need to change it after starting the stream here, because this is where everything is happening. So let's drop this down. After starting the stream, we need to do something here so that we can be able to change the gain while audio is running. So we'll do something we call a simple loop. So while, we can say while true, exactly true. Okay, so while true, you're going to say exactly. So I like how IntelliSense is actually telling us 1 to quit or -1 to quit. Okay. So we have the float new gain. Then we have the std in, then new gain. So if the new gain is less than 0.05, we are breaking. Yeah, we don't need that. So we are breaking. Then so the new gain, so I can modify this new gain we can try to modify these. What I'll do, let me do this. We shall say new gain will be equal to std, then we're going to clamp it, the new gain. So we're going to clamp it with the new gain. Then we shall say, yeah, that's now correct. Then now we shall store it. We shall now do a gain store and the new gain. So we shall output updated gain level load. Yeah, so we can just see gain updated too, or it's still fine, it's still okay. Now I want you to notice something very important here. Let me save this. We have not touched our audio buffers here. We've not touched anything. We only change a number. The audio thread actually pulls that number when it needs it. So this is the core DSP architecture. Now, when gain is equals to 1.0 in this loop, when gain is equals to 1.0, it will be an original volume. When gain is at 0.5, it is at half amplitude. When gain is 0.0, it means it is silent. So this leads naturally to what we call decibels and something we call logarithmic loudness. So we are going to do this in the future videos to come. But for this, we just wanted to understand how gain works and the basics. So let's try to run it. So go to our terminal, say make, then let's run it. So input 2, output 3. Yeah. So current gain level is 0. So I'll try to put it at 1.0. And there we go. So it is very loud. So as I put to 0, it is at, there is nothing. It is silent. All right, let's try to put it at 4.0. See. So you see, it is actually clamped. Yeah. Okay. So I will close this. -1 to quit. Okay. So by now, I hope you've understood this episode. If you have any questions, you have any problem, you can write it down in the comments. We actually value your comments and your feedback on our first video, and we try to improve on this second video. Thank you so much for watching. Goodbye. See you in the next episode.